All right, here we go. We're back for part two. Hopefully, there's not part three, but all right, we're going to talk about a significance test is a formal procedure for using observed data to decide between two competing claims. So here we go. We're going to have a lot of fun with this one for the rest of the year, even. So much fun. I'm going to actually dial this up a notch. So these are going to be your hypotheses, plural. There will be two of them that we'll be spending a lot of time. There is the null hypothesis. We will refer to it as the ho, ho, ho. No, I'm just kidding. It's just a ho. And it is the statement of no difference. That means there's no difference here. There's nothing to see here. Nothing remarkable. No, nothing. The alternative is the other hypothesis. We will refer to it as the ha. And it will always be our statement of there is some kind of change. There's a difference. There's a greater ability, go figure, or less ability. So this is your change. So the first one, the null, is always no difference. Null, no difference. And the alternative is always your hypothesis about some kind of change. Okay? So the claim about the population that we're trying to find evidence. I guess I could have read that too. So example down here, player claims that over his career he can make 80% of his free throws. We claim that he makes less than this amount. So if there's no difference, you would say this player, strange font I'm writing in today, this player makes, and you're just going to put the original, makes 80% of his free throws. Free throws. So remember the first one, the ho, no difference. Okay, for the ha, this is going to be our claim. We're going to say this player, we'll keep it real simple, makes less than 80% of their free throws. Okay, so the first hypothesis, the ho, will always be the original, and then the second one, the ha, the alternative hypothesis, will always be the statement of change. Okay, got some even better examples coming up. So here we go. Look at the dog. All right, here we go. Claim one. Cardinals, talking baseball here, had the same ability to win at home and on the road. Okay, and the difference in performance was due to just random chance. Claim two, the Cardinals had a greater ability to win at home. So, talking about the home crowd, you have a home advantage, that kind of thing. So, we got two claims here. To prove claim two is correct, this is a change, right? We have to have convincing evidence that claim one is not true. Okay? And we'll always assume that the original claim is true. Okay, I like what they said here, innocent until proven guilty. So we'll always assume you claim one is true. In other words, the null. Okay, I'm just going to put that here. This is the null, which would be your HO. We'll always assume the ho is true unless we have evidence, okay, to proceed to claim number two. So this is going to be the ha. This is your alternative, saying that you have a greater ability to win. So we can conclude the Cardinals have a great ability to win if it is unlikely that the difference in performances was due, and here we go, random chance. We're going to need to take random chance out of the whole equation. So let's get to the data. We've been here before. So we had what the home winning percentage was 75%, if I remember right, and the road was 38%. So it definitely looks like a decrease. Okay. So let's move it on to the next slide. So null describes your initial belief. There's no change. Alternative. Okay, saying that again. So let's write it out like this. So if you're going to write the null hypothesis to this, you could say Cardinals and you're saying there's no change in ability. I'm going to say have the same ability to win. Like there's no difference. Whether or regardless, whether at home or on the road. Okay, so for the haw, we're going to go Cardinals have a greater ability to win at home. Okay, so there's your ho, there's your ha. And again, we always have to assume this one's true until we have evidence that we can come down here and make this statement. So next slide. Do quarterbacks have a greater ability? So another example. Talking about Mr. McNabb here. Let's see here. Do quarterbacks have a greater ability to complete passes when the weather is warm? When the weather is warm, you certainly think so. Nobody likes to do anything when it's really cold. So to investigate, we're going to compare the passing completion percentages for McNabb in games 50 degrees or warmer and in games under 50 degrees. So we're going to state the null and hypothesis. So let's just say that Donovan McNabb has the same, so no difference, same ability to complete a pass regardless of temperature. Okay, that's pretty good. So Donovan McNabb has the same ability to complete the pass no matter what temperature it is. And then for the ha, we're going to say he has a greater ability to complete a pass when the weather, be specific here, is 50 degrees or warmer. Okay. All right, so another good example of the ho and the ha. Moving on, last screen. So here we go. 2009, 2010 Orlando Magic. Were they a good second half team? That is, did they have a great ability to win after the All-Star game midway through the season? So they had a record of 36-18 before the All-Star and a 23-5 record after the All-Star. So let's fill it in. We'll get a table going and run from there, and then they want the hypothesis down here. So here we go. So before the All-Star, they were 36-18. That means they had 36 wins. They had 18 losses. And we'll go ahead and add that up. So 36 plus 18, we'll take it up to 54. So 54 total games before the break. And again, they won 36 out of those 54. After the All-Star game, they went 23-5, which means they won 23 of those games, lost only 5, which means they had a grand total of 28 games after. Okay, so if you're going to go for that percentage, you're going to take 23 out of 28, which is going to be good. So here we go. Need a little room to write. So before, it'd be 36 out of 54, which is going to be a grand total of 36 divided by 50. So that's a 67% chance of winning. And let me go up here. After the All-Star break, they were 23 out of 28. Out of 28, which is going to be 82% winning percentage. Okay, So going back over here, I'm going to have to shrink this down because I didn't give myself very much room. So we'll put 50, 60, 70, 80, 90, and okay. So 50's right here, 40, 30, 20, 10. And definitely this is percent going out this way. Okay. All right, and down here we're going to put before and after. There's two categories. All right, so before they had a 67% chance, which is probably going to put it right in there. 67%. And then after it was a nice 82, which is going to be 67, 80, which is going to be way up here. All right. So definitely looks like they had a greater performance after. So let's check out the hypothesis because this is really what we're here for today. So we're going to put the ho right here. We're going to put the ha right here. So again, the null hypothesis of the ho is representing no change. So we're going to say that the magic had the same ability before and after the break. And I'll put all-star break. Okay. So again, that's the null, the ho. Okay, statement of no difference. They have the same ability either way. So for the ha, we're going to say the magic had a greater ability to win after the all-star break. Okay, so there we go. Good example. Ripped from the headline. So Orlando Magic, 2009, 2010. And it won't be long. Next few lessons, we're going to be talking about actually getting the evidence to assert whether you do have that great ability or not. Okay. And again, that's all going to go back to random chance. So, but that finishes for today, y'all. Appreciate you hanging around.